There is a route that Simón Bolívar's doctors carried in their saddlebags across the Andean mountain range, a route that had already saved Europe from a shameful epidemic 200 years earlier, and which, in the 20th century, was dismantled in laboratories in New Jersey and Stuttgart to build medicines that today are worth billions of dollars a year, without the communities of Darién, nor the heirs of the indigenous botanists who named it, nor the Colombian peasants who harvested it for generations, having received a single penny. It's not a metaphor. It's not an exaggeration. It's a case documented by the United Nations, mentioned by name in the Brundtland Commission report, and cited in the preparatory debates for the Convention on Biological Diversity signed in Rio de Janeiro in 1992. It has a plant, a name, dates, and registered laboratories. And most people who have ever taken a birth control pill, a corticosteroid for inflammation, or certain hormonal treatments have unknowingly paid for the chemicals that this root provided free of charge to those who discovered it without ever calling it a discovery. The plant is called Sarsaparilla. Botanists know it as Smilax regelii, and its close relatives within the same genus. But before botanists gave it a Latinized name, it already had names in dozens of languages across the Americas. It already had uses. It already had a history. And that history begins long before Bolívar crossed the highlands. Long before Spanish galleons loaded their holds with dried roots in Nombre de Dios and Cartagena de Indias. Long before doctors in Seville and Lisbon desperately wondered what could stop the most shameful epidemic in Europe. To understand why this root matters, we must understand the world it fell into when it reached European hands. We are talking about the 16th century, a continent that had had less than 50 years of contact with the New World and was already burdened by a new disease for which it had neither a stable name nor an effective treatment. They call it the French disease in Italy, the Italian disease in France, the Spanish disease in the Netherlands, the Neapolitan disease almost everywhere. It is syphilis, and Europe is terrified. European treatments of the time were, in modern terms, little short of torture. Mercury in massive doses applied through friction, steam inhalation, and preparations that destroyed teeth, bones, and the nervous system. Patients lost their hair, skin, and sensation. Many died from the treatment before they died from the disease. Those who survived were scarred for life. Doctors knew mercury was poison. They administered it anyway because there was no alternative. And then the roots arrived. The first shipments of sarsaparilla began arriving in Seville around 1530. They came from Darién, from the Caribbean coast, from the tropical hillsides where the plant climbed trees with its sturdy tendrils and extremely long roots that could reach 1.5 meters underground. They arrived accompanied by reports from missionaries and landowners. The indigenous people of those regions, they said, used this root to treat what they called blood ailments, persistent fevers, skin sores, joint pain, and persistent inflammation. They had been using it for centuries. They possessed a wealth of accumulated knowledge about it that no European physician of the time could match. The doctors in Seville tried it. The results, compared to mercury, seemed miraculous. The patients improved. The symptoms receded. The skin healed. And, above all, the sick did not die from poisoning during the process. Sarsaparilla was not a definitive cure for syphilis. Today, we know that Treponema pallidum, the causative bacterium, requires antibiotics to be completely eliminated. But it produced remission of symptoms in a way that mercury treatment could never match with the same certainty. Demand skyrocketed in a matter of years. Between 1540 and 1600, sarsaparilla became one of the most profitable exports of the Viceroyalty of New Spain and the Viceroyalty of Peru. Records from the General Archive of the Indies in Seville document regular shipments. The dried root was packed in leather bundles, marked with seals of origin, and shipped on the galleons of the Indies fleet, along with silver from Potosi and cacao from Tabasco. It was not a marginal remedy. It was a strategic commodity, monitored by the House of Trade, subject to taxes, and coveted by merchants in Venice, Amsterdam, London, and Lisbon. The physician Gonzalo Fernández de Oviedo chronicler of the Indies and one of the first Europeans to systematically describe American plants, already mentioned sarsaparilla in his General and Natural History of the Indies, published in 1513 in its first part. Oviedo was not a botanist in the modern sense, but he was a meticulous observer, and his description of the indigenous use of the root for skin and blood diseases coincides with what other chroniclers from very different geographical locations would confirm decades later. But the most important voice of the 16th century on this plant is that of Nicolás Monardes, the Sevillian physician who never set foot in America but dedicated his life to studying the plants that arrived from it. In 1565, Monardes published his Medicinal History of Things Brought from Our West Indies, a work that would be translated into English, Latin, Italian, and Flemish, becoming the first major text on American pharmacology with European distribution. And in that text, sarsaparilla occupies a central place. Monardes describes the preparation method. The root is cleaned, cut into pieces, soaked for 12 hours in cold water, then boiled for several hours until a dark, slightly bitter liquid is obtained, with an earthy, sweetish aroma that those who described it compared to licorice root mixed with damp forest soil. This liquid was drunk for extended periods, weeks, sometimes months, following a strict regimen that included abstaining from cold foods, moderate exercise, and controlled sweating. The sarsaparilla sweat cure method, as recorded by Monardes, was actually a European adaptation of indigenous therapeutic practices that informants from Darién and the Caribbean had reported to the first Spaniards. What Monardes couldn't know, what no one would know for another 4 centuries, was why it worked. The chemical mechanism would remain hidden until 20th century biochemistry named the molecules inside the root. And when they finally discovered it, what they found inside that root would forever change the global pharmaceutical industry. But that comes later. For now, let's stay in the 16th century and follow the plant's route north and south, because the story of sarsaparilla isn't just the story of Europe and syphilis. It's also the story of America and malaria. And it's in that second story that Bolívar appears. Malaria, called paludic fever, tertian fever, quartan fever, or simply the fevers for centuries, was a disease that decimated armies with an efficiency no human enemy could match. The Plasmodium parasite, transmitted by the Anopheles mosquito, was invisible to the medicine of the time, but its effects were starkly visible. The afflicted would enter cycles of chills, followed by high fever, followed by profuse sweating, repeated with almost mechanical regularity every 2 or 3 days, consuming the body until it was unable to stand. In an army on the campaign, without access to hospitals, without sufficient quinine, the bark of the cinchona tree, which was the primary anti-malarial of the time, the fevers could incapacitate a third of the troops in a matter of weeks. During the South American Wars of Independence between 1810 and 1825, medical logistics were a constant and serious problem. Patriot and Royalist armies fought in tropical and humid terrain where the Anopheles mosquito thrived. Field doctors faced chronic shortages of medicines, especially quinine, whose production was controlled by the Spanish colonial system and whose supply became irregular or impossible in hostile territory. In this context, local doctors and healers resorted to whatever was available in the environments they traversed, and in the northern regions of South America, present-day Colombia, Venezuela, and Ecuador, what was available included sarsaparilla. Campaign memoirs and medical diaries from the independence era, many of them collected in the archives of the National Academy of Medicine of Colombia and the National Library of Venezuela, mention the use of decoctions of local roots to treat fevers. The precise distinction between sarsaparilla and other fever-reducing plants used concurrently is not always clear in these documents. The field doctors were not systematic botanists, and often the popular name sarsaparilla was applied to several species of the same genus, Smilax, depending on the region. But the pattern of use is consistent. When quinine was unavailable or scarce, the roots from the Darién and Chocó rainforests were the next best option. Francisco de Paula Santander, the New Granadan general who coordinated much of the logistics for the Bolivarian army, mentioned in his correspondence the difficulty of procuring medicines during the campaigns of 1819 and 1820, the most arduous period of the marches across the plains and the crossing of the Andes. During that same period, the expedition that crossed the Pisgah moorland, one of the most dramatic moments in the entire history of American independence, decimated the army due to exposure to the cold and altitude. But those who survived that crossing later faced the fevers of the eastern plains with what local herbalists provided them. Sarsaparilla was among those remedies. Here we must be precise and avoid romanticizing the issue. Sarsaparilla is not, and never was, an anti-malarial with the potency of quinine. The alkaloid quinine, extracted from Cinchona officinalis, acts directly on the Plasmodium parasite with an efficacy that the chemistry of sarsaparilla cannot replicate. What sarsaparilla did do, and this is supported by both historical accounts and modern chemical research, was act as an anti-inflammatory, reduce secondary fever, and support the body's recovery during the febrile process. It was a supportive treatment, not a specific one. But in field conditions, without a hospital, without quinine, that support could mean the difference between a soldier who recovered in 3 weeks and one who did not. Bolivar's army was not the only one to use sarsaparilla during that period. The Patriot forces of Mexico, during the War of Independence from 1810 to 1821, and San Martin's armies in the Southern Cone, also turned to local plants to treat illnesses that no European supply could address from afar. Field medicine in the American Wars of Independence was, to a large extent, indigenous and Creole medicine, repurposed under pressure. It was the knowledge of healers, market herbalists, and doctors who had learned through the daily practice of colonial cities rather than from the books of Seville that kept those armies going. But the story that matters here is not just that of its historical use. It's what followed. Because while sarsaparilla fed soldiers and soothed the sick on both sides of the Atlantic, while the markets of Cartagena, Veracruz, Lima, and Guayaquil sold its dried roots alongside cinnamon and ginger, while the herbalists of Seville and the pharmacies of Madrid included it in their prescriptions as naturally as they included rosemary or chamomile, somewhere in the future a laboratory waited. And that laboratory wasn't going to pay for what it was going to find. Sarsaparilla entered the 20th century carrying centuries of documented use, but without any mechanism to protect the knowledge that had accompanied it on that journey. No patent was possible for a plant that millions of people on 3 continents had used freely for 400 years. The knowledge was public. The plant was wild. The communities that had preserved it, that had passed down from generation to generation the methods of preparation, the dosages, the harvest seasons, the differences between species, those communities had no legal mechanism to claim ownership of what they knew. And that was exactly what made what happened next possible. In the first half of the 20th century, the Western pharmaceutical industry faced a huge problem. The demand for cortisone and steroid hormones was growing faster than the capacity to produce them. Cortisone had been identified as a treatment for rheumatoid arthritis by American researchers Edward Kendall and Philip Hench in the 1940s, work that would earn them the Nobel Prize in Physiology or Medicine in 1950. The problem was that extracting cortisone from animal sources was an incredibly laborious and expensive process. It took kilograms of bovine adrenal glands to produce even minimal quantities of the drug. The price was prohibitive, and once its anti-inflammatory effects became known, demand skyrocketed. The laboratories were desperately searching for a more accessible raw material, a chemical precursor that would allow them to synthesize cortisone and related hormones efficiently and economically. The researcher who discovered it was named Russell Marker. He was an eccentric American chemist obsessed with plant steroids who in the 1940s had developed a process known today as marker degradation that allowed certain plant molecules called sapogenins to be converted into progesterone and from there into a cascade of synthetic steroid hormones. Marker knew that some tropical plants contained these sapogenins in usable quantities, and he knew that among the best candidates were plants of the genus Smilax. Sarsaparilla roots contain steroidal saponins, particularly sasasapogenin and smilagenin, which are structurally very close precursors to progesterone and other steroids. Marker's degradation allowed these molecules to be converted into starting materials for hormone synthesis with an efficiency that no animal source could match. Marker left his position at the University of Pennsylvania, settled in Mexico, and began searching for plants containing these sapogenins in sufficient concentrations to be economically viable. The plant that ultimately became central to his work was the cabezón, or cabeza de negro, Dioscorea mexicana, not sarsaparilla. But subsequent research by European and American laboratories repeatedly returned to Smilax americana as an alternative or complementary source of steroidal precursors. And here lies the core of the problem. What the laboratories patented wasn't the plant. It wasn't the root. It was the synthesis process, the degradation method, the derived molecules. Perfectly legal patents under the intellectual property law of the time, and to some extent under current law, but those patents built multi-billion-dollar industries on a knowledge base that no one paid for. The knowledge that the roots of Smilax americana contained those useful molecules didn't come from a laboratory. It came from centuries of indigenous use. It came from the herbalists of Darién who showed the first Europeans how to clean and cook those roots. It came from the healers who passed down the knowledge of which sarsaparilla varieties were most potent and in what season to harvest them. It came from generations of women who prepared the decoction in communities in Colombia, Guatemala, Honduras, and Mexico over the course of 400 years. That knowledge was the starting point. The pharmaceutical industry took it, stripped it of its cultural context, subjected it to chemical analysis, and patented the fragments it found useful. The process was completely legal and completely unjust. The Brundtland Commission, the World Commission on Environment and Development, chaired by former Norwegian Prime Minister Gro Harlem Brundtland, which published its report, Our Common Future, in 1987, identified precisely this type of situation as one of the most pressing problems at the intersection of development, ecology, and justice. The report did not specifically name sarsaparilla in its main text, but the preparatory discussions and working papers surrounding the Commission did document the case of American medicinal plants, and in particular Smilax, as a prime example of what experts were beginning to call biopiracy, the appropriation of biological knowledge from local communities without acknowledgement or compensation. The concept of biopiracy was later developed and popularized by researcher and activist Vandana Shiva and economist Pat Mooney, and it became a central theme in the negotiations that led to the Convention on Biological Diversity, signed at the Earth Summit in Rio de Janeiro in June 1992. That convention was the first legally binding international instrument to recognize the sovereign right of countries over their biological resources and the right of local communities to benefit from the traditional knowledge associated with those resources. It was, in part, a belated recognition that what had happened to sarsaparilla could not continue to happen. But it came too late for many communities, and its actual implementation, decades after it was signed, remains incomplete, uneven, and constantly contested by the interests of the pharmaceutical industry and the developed countries that hold its patents. Meanwhile, on the humid slopes of the Darién region of Panama and Colombia, in the cloud forests of Guatemala and Honduras, and in the ravines of northern Venezuela, the plants continued to grow. The communities that had known them for centuries continued to live near them, and not a single check had arrived yet. That is the weight this root carries. 400 years of accumulated knowledge, centuries of documented use, galleons that crossed the Atlantic laden with its cargo, soldiers who regained their strength on the Venezuelan plains thanks to its infusions. Syphilis patients in Seville who survived without the poison of mercury. And finally, laboratories that found in its molecules the starting point for industries that owe nothing to anyone. There's an archive in Seville where the records of those galleons are kept. Captains' names, sailing dates, cargo weights, prices paid in Caribbean ports. The numbers are all there, written in ink from 4 centuries ago that hasn't faded yet. But on none of those pages appears the name of the person who taught the first European to recognize the plant among the vegetation of Darién, to dig in the earth to find its root, to clean it, to boil the right amount in the right water for the right amount of time. That name was never written. And that absence is the oldest wound in this story. The laboratories didn't arrive at the interior of the sarsaparilla root by chance. They arrived there because centuries of documented use pointed them exactly where to look. When 20th century biochemists began systematically analyzing American medicinal plants, they had an enormous advantage at their disposal, one they rarely acknowledge in their publications: a map. Not a geographical map, but a map of knowledge. Colonial chronicles, convent herbals, records from New Spain pharmacies, reports from Jesuit missionaries in Paraguay and the Colombian Chocó, and the observations of physicians from José Celestino Mutis's Royal Botanical Expedition to the Viceroyalty of New Granada, an expedition that began in 1783 and, for decades, systematized the botanical knowledge of what is now Colombia and Venezuela. All this body of work pointed time and again to the same plants as being effective against the same ailments. The Mutis expedition is a particularly revealing case. Mutis, a physician and priest born in Cadiz who spent most of his scientific life in Bogotá, compiled the most complete herbarium of American plants in existence at the time. His collaborators, among them the young Francisco José de Caldas, the New Granadan cartographer and botanist, collected thousands of specimens, documented indigenous and mestizo uses, and prepared plates of artistic precision that are now preserved in the Royal Botanical Garden of Madrid and remain valuable scientific references. Among the plants documented by the Mutis expedition were several species of Smilax from northern South America. Mutis recorded their local uses with the same rigor he applied to their morphology. His notes are, strictly speaking, the first systematic European record of the use of sarsaparilla in the region that 2 decades later would become the scene of the Bolivarian Wars of Independence. That knowledge passed to herbaria. Herbaria passed to archives. Archives passed to 20th century researchers. And 20th century researchers turned that starting point into millions of dollars in patents without anyone in the chain bothering to ask where the original information came from. The chemistry of sarsaparilla began to be systematically documented in the first half of the 20th century, but the most revealing study of its active components came in later decades. The family of compounds contained in the root, steroid saponins, particularly sarsasaponin, smilaginin, sarsasapigenin, and parylin, began to receive serious attention in the international scientific literature from the 1950s and 1960s onward, in the context of the search for precursors for the synthesis of steroid hormones, which we have already mentioned. But modern research on sarsaparilla has not been limited to steroids. Over the past 3 decades, the pharmacological profile of the various species of Smilax americana has been studied from very different angles, and the results are consistent with the historical use of forms that 50 years ago would have seemed inexplicable, but are now perfectly legible in biochemical terms. A study published in the Journal of Ethnopharmacology in the 1990s, which reviewed the available literature on the traditional medicinal applications of Smilax americana and compared those uses with the chemical evidence then available, found a remarkable correspondence between the historically documented uses, anti-inflammatory, antipyretic, anti-rheumatic, and blood purifier, and the proposed mechanisms of action for saponins and other compounds identified in the root. The study noted that Smilax saponins have demonstrated anti-inflammatory activity in animal models, and that some of these compounds showed the ability to inhibit the synthesis of prostaglandins, which are key mediators of the inflammatory process. Put more simply, the plant did what previous generations said it did, and chemistry could begin to explain why. Subsequent research expanded on this profile. A team from the National Autonomous University of Mexico, working from the Institute of Chemistry during the early 21st century, comparatively analyzed the steroidal saponin content of different Mexican Smilax species, particularly those growing in the mountains of Puebla and the humid regions of Veracruz, and found significant variations in the concentration of active compounds depending on altitude, harvest season, and the part of the root analyzed. These results explained something that traditional herbalists had always known empirically. Not all sarsaparilla is the same. Not all of the year's harvest is of equal value. and roots from certain microclimates are superior to those from others. The knowledge that seemed like folklore turned out to be applied pharmacognosy refined over centuries. The research group at the Center for Research and Advanced Studies of the National Polytechnic Institute has also worked on compounds from plants of the genus Smilax found in Mexico, particularly their antiparasitic activity. Some preliminary studies have indicated that certain Smilax extracts show in vitro activity against parasitic protozoa, which directly resonates with the plant's historical use in treating fevers of parasitic origin, including the fevers faced by the independence armies in the tropical plains. Outside the Spanish-speaking world, Korean and Chinese research on Asian Smilax, plants of the same genus with a history of use in traditional Chinese and Korean medicine, has yielded relevant data that also shed light on their American relatives. A study published in the journal Phytomedicine in the early 21st century documented that extracts of Smilax China showed anti-inflammatory activity in animal models comparable to that of certain commonly used non-steroidal anti-inflammatory drugs, NSAIDs, without the latter's gastrointestinal side effects. Given that the saponins of the Asian and American species are structurally very similar, these results can be extrapolated with caution, but they are extrapolatable. One aspect of Sarsaparilla's pharmacological profile that has gained interest in the last 20 years is its potential role as a hormone modulator. The steroidal sapogenins in the root, particularly sarsaparilla, have a molecular structure remarkably similar to that of hormones like testosterone and progesterone. This doesn't mean the plant is a natural anabolic equivalent to synthetic steroids. That idea has circulated for years in the bodybuilding world and is, in its most extreme formulation, an exaggeration. What research shows is more nuanced. Sarsaparilla sapogenins can act as precursors or modulators in certain hormonal pathways, and some studies have documented effects on androgen receptor activity in cell models. Research in this area remains preliminary, and translating those results directly into clinical recommendations for humans would require trials that have not yet been conducted at the necessary scale. What is well documented and what is most directly relevant to the plant's historical use is its anti-inflammatory activity and its ability to bind to certain bacterial endotoxins in the digestive system, a property that could partially explain why prolonged treatment with sarsaparilla decoction produced improvement in patients with infectious diseases such as syphilis, whose progression involves intense systemic inflammation. The plant did not kill the bacteria, but it could reduce the inflammatory burden that the bacteria produced, and this resulted in observable clinical improvement. This distinction between a treatment that eliminates the cause and a treatment that mitigates the effects is crucial for understanding both the true value of the plant and the limits of that value. Sarsaparilla is not penicillin. It does not cure syphilis. It is not an anti-malarial comparable to quinine. But it has real, measurable, pharmacologically understandable effects on inflammatory processes, on certain parasites in preliminary studies, and on hormonal modulation in specific contexts. And these real effects are what sustained its use for 500 years on 3 continents. The users were not mistaken. They were not administering placebos. They were observing real results that 20th century biochemistry would confirm 4 centuries after the first commercial transaction in the ports of Seville. If these stories are holding you back, if you feel like someone held onto this for too long, subscribe to the channel. Every week we open another case that should have come to light sooner. Sarsaparilla did not disappear. That is the first thing to say, because the narrative of total loss, however emotionally powerful, is not accurate. The plant continues to grow in the rainforests of Central America and northern South America. It is still harvested by communities in the Darién, in Chiapas, and on the Atlantic slopes of Honduras and Guatemala. It is still sold in the Sonora market in Mexico City, at the medicinal plant stalls in the La Merced market, in neighborhood herbal shops in Bogotá and Medellín, in natural health stores in Buenos Aires and Santiago, and in herbal shops in Granada and Seville, where the staff still know its name and can describe its uses. In the Tlacolula market in Oaxaca on Sunday mornings, amidst the copal incense stalls, bundles of epazote and piles of hoja santa leaves, sarsaparilla appears, sometimes as a dried root tied with ixtal thread, sometimes as a brown powder stored in cellophane bags with a handwritten label. The vendors who offer it, many of them Zapotec women who learned the trade from their mothers and grandmothers, know its uses with a precision that rivals a pharmaceutical leaflet. They know what it's used for, they know how to prepare it, they know when not to use it. This knowledge hasn't been lost. It has survived on the margins, in the markets, in the kitchens, in the recipe books passed down through families of healers. Outside the realm of informal markets, the medicinal plant recovery movement has gained institutional momentum over the past 20 years. The Center for Research on Biotic Resources at the Autonomous University of the State of Mexico, the Ethno-Botanical Garden of the American Center for Rural Development and Agriculture, and various initiatives of the National Commission for the Knowledge and Use of Biodiversity in Mexico have worked on the systematic documentation of traditional knowledge about medicinal plants, including the various species of Mexican Smilax. The goal is not only scientific, it is also legal. To create documented records of traditional knowledge that can serve as evidence of prior ownership in the event of future intellectual property disputes. In Colombia, Afro-Colombian and indigenous communities in the Chocó region, the biogeographical area where sarsaparilla was one of the first colonial exports, have participated in projects to promote the value of local medicinal plants. These projects are driven by the University of Antioquia and organizations such as the Major Community Council of the Comprehensive Peasant Association of the Etrado. They work in two ways, preserving knowledge and developing sustainable use mechanisms that generate income for the communities themselves, thus partially closing the cycle of uncompensated extraction that characterized the colonial and industrial centuries. In Spain, the story of sarsaparilla has a different but equally revealing angle. During the 16th and 17th centuries, the plant was one of the most expensive and coveted remedies in Spanish pharmacies. Its presence in the prescription books of the Royal Pharmacy of El Escorial, founded by Philip II as part of his project to gather all the medical knowledge of the known world in one place, is documented in the inventories of the Simancas archive. The Royal Pharmacy stored the root with the same care it gave to theriac and bezoar stones, the most valuable remedies of the time. Today, the Herbarium of the Royal Botanical Garden of Madrid, an institution founded in the 18th century under Charles III as part of the Enlightenment tradition of cataloging and systematically studying nature, maintains historical records and herbarium specimens that document the role of sarsaparilla in the Spanish pharmacopoeia of past centuries. And in the herbalist pharmacies of neighborhoods like Malasaña in Madrid, Raval in Barcelona, and Albaicín in Granada, dried sarsaparilla root is still available, legally sold as a food supplement and as a medicinal plant of traditional use under the regulation of the Spanish Agency for Medicines and Health Products. Regarding contemporary practical use, the regulatory situation varies by country. In Mexico, the Federal Commission for Protection Against Sanitary Risks recognizes sarsaparilla as a medicinal plant for traditional use, although without formally approved clinical indications for medical use. In Spain, it is included in the Spanish Agency for Medicines monograph on medicinal plants as a traditional herb used to support kidney elimination function and as a mild anti-inflammatory. The World Health Organization, in its series of monographs on selected medicinal plants, has collected information on Smilax as part of its effort to systematize global knowledge on plants with traditional use. For those wishing to incorporate sarsaparilla into their daily lives, the most historically documented method is a root decoction. Between 10 and 15 grams of finely chopped, dried root, boiled in 1 liter of water for 20 to 30 minutes, left to steep for another 15, strained, and consumed in small cups throughout the day, no more than 3 times a day. This is the method described by Monardes in the 16th century, still recommended by Mexican and Colombian herbalists today, and which current research suggests has a solid chemical basis in terms of extracting the active saponins. The contraindications are real and should not be minimized. First, prolonged use at high doses can cause gastrointestinal irritation, nausea, and diarrhea. Second, the saponins in sarsaparilla can interact with certain medications, particularly digoxin, a heart medication, and with hypnotics that are eliminated by the kidneys, accelerating or altering their absorption. Anyone taking prescription medications regularly should consult a doctor before using sarsaparilla on a sustained basis. Third, there is insufficient data on its safety during pregnancy and breastfeeding, so it is recommended to avoid it during these periods as a precaution. And fourth, a particularly important point in Mexico and Central America, several plants are commonly called sarsaparilla in different regions, even though they do not belong to the genus Smilax, some of which have different toxicity profiles. Correct identification of the species is essential before any sustained use. Seeds of Smilax americana are not readily available in commercial nurseries. The plant is primarily propagated by rhizome division. Some botanical cooperatives in Oaxaca and Chiapas, as well as specialized herbalists in Mexico City and Guadalajara, offer rhizomes for cultivation. The plant requires a warm, humid climate, well-drained soil, and something to climb. It is a vigorous vine that can reach several meters in length and, once established, needs little care. In Spain and other Mediterranean regions, Smilax aspera, European sarsaparilla, a close relative of the American species, grows wild in many areas of the Mediterranean coast and southwest, and its properties are similar, though not identical, to those of the American species. The issue of biocultural justice, the political heart of this story, has seen concrete but incomplete progress. The Nagoya Protocol on Access to Genetic Resources and the Fair and Equitable Sharing of Benefits, adopted in 1915 under the Convention on Biological Diversity and which entered into force in 2014, obliges signatory countries to establish mechanisms for access to and benefit sharing of genetic resources and associated traditional knowledge. Mexico, Colombia, Peru, and Spain have ratified the protocol. Its effective implementation is another matter. The specific mechanisms for benefit sharing with indigenous and local communities remain fragile, bureaucratic, and frequently dependent on the legal capacity of the communities themselves to claim their rights. There are, however, success stories that indicate this path is possible. The model of the Chiquitana Mission's phytomedicine program in Bolivia, the initiatives of the Andean Medicinal Plants Network, coordinated by the Pontifical Catholic University of Peru, and the access and benefit sharing agreements negotiated by indigenous communities in the Colombian Amazon with research institutions. All these examples show that it is possible to build a model in which scientific research and traditional knowledge are related in terms of equity, not extraction. The name of the person who taught the first European to dig in the Darién soil and extract that root is not in any record. That name was lost before anyone thought it worth writing down. But the names of those who harvest the root today, the names of the women in the Tlacolula market, the names of the farmers in Chocó, the names of the researchers in Bogotá and Mexico City working to document what remains, those names do exist. Those names can still be written down. That is the difference between a story that is completely lost and one that still has the possibility of ending differently. Subscribe to this channel. Every week we unearth a chapter from the archives that no one should have forgotten. There's an image that's been haunting me since I started researching this story. It's the image of a root crossing the Atlantic in the hold of a galleon, wrapped in leather, marked with the seal of the Casa de Contratación, bound for a pharmacy in Seville named after a Spanish doctor. The root doesn't know it crossed an ocean. It doesn't know it changed the course of an epidemic. It doesn't know that 4 centuries later, someone will put it under a microscope and find inside it a molecule worth millions. It knows nothing of patents, protocols, or boards of directors. It simply remains the same root that someone dug up with their hands in the Darién region, the same root that an unnamed woman first prepared over a fire that went out long ago. And it keeps growing. That, too, is a form of victory.